All right, we're in unit number 2 still, and we are going to encounter probably the most important concept we'll cover all year long, and that is acceleration. In the previous video, let's just do a quick review. In the previous video, we said anytime you speed up, slow down, or turn, we call that a change in velocity. Well, we're going to give that another name. So instead of saying change in velocity, we're going to call that an acceleration. So any change in velocity we say is accelerating. And that's what you got to know. We're going to use that concept all year long, all the time. So you need to know that anytime you speed up, slow down, and turn, that's a change in velocity. And anytime you change your velocity, we call that an acceleration. You could also say, anytime I speed up, slow down, and turn, that's an acceleration as well. So there's any number of different ways that you can run through and talk about changing or accelerating. So accelerating can be speeding up, slowing down, turning. A lot of people have a hard time with the concept of slowing down as accelerating or turning as an acceleration. You gotta kind of get that out of your brain. I think when you walked into this classroom, maybe when you first started seeing this video, you think, if I asked you what would acceleration be, well, acceleration would be speeding up. And you got to remember that acceleration, in terms of physics, isn't just speeding up. Acceleration can also be slowing down, and acceleration can also be turning. You got to be able to get that straight and keep that in your mind. So we're going to run through a couple quick definition of acceleration, and then we'll run through a couple examples as well. So here's acceleration. It's the time rate of change in velocity. It's a little fancier than what I gave to you earlier. The reason is that we're going to use this definition a little later on, but for right now, you just need to know the acceleration is a change in velocity. Alternate definition: the rate, which is how fast, an object velocity has changed. So let's talk about it right now. So not only is acceleration speeding up, slowing down, turning, but acceleration is also how quickly you do one of those three things. How quickly you speed up, how quickly you slow down, or how quickly you turn. So there's a time element inside or tucked into acceleration. Anytime the velocity of an object has changed in any way, the object has accelerated. The abbreviation for acceleration is an A with an arrow. That shouldn't surprise you because when we turn, that has to do with a direction, so it's going to be a vector. Eventually, we will just drop the arrow and assume, I think I spelled that right, assume it's there. Acceleration is a vector quantity because direction is indicated. All right, if you were in class, we would take a look at a Hewitt video and basically show you what he had to say about acceleration, and we would also show you a hilarious website on launching the, or not, sorry, I'm thinking of a different website. Another website about launching the phone. So when Steve Jobs launched the iPhone, he talked about the fact that all iPhones have an accelerometer built into them. An accelerometer basically is a device that senses changes in velocity. So, for example, if you were reading or looking at your phone, and I don't have an iPhone, so maybe I'll use this scale as an example. So let's say I had my iPhone here, I was holding it landscape-wise, and I switched it and I rotated it this way. You know that when you use an iPhone, the image rotates as you rotate the phone. Well, how does it sense that? How does it know that? Well, it's got actually an accelerometer built into the camera, and that accelerometer senses any change in motion, speeding up, slowing down, and turning. And if you turn your phone, it senses that and says, "Oh, I need to switch the orientation of the image so that the operator of the phone can read it correctly or read it in the correct orientation." And so without that accelerometer in the phone, you'd either always be reading landscaped or always be reading it vertically, and you wouldn't be able to have that option available to you, which is kind of cool. All right, the next one, demonstration. Raise your hand. Part 2. We've I would do this in class, but this is a pretty quick one. I would basically have students raise their hand when they see me accelerate. Well, since we already know that acceleration is a change in velocity, and a change in velocity is speeding up, slowing down, and turning, that's basically what this is. So this is going to be speeding up, slowing down, and turning. So anytime an object accelerates, the velocity, not speed, the velocity of the object is changed automatically. So the next question for you is what are those three accelerations in your car? What are the three devices in your car that can cause the car to accelerate? Well, most people pick up one real quick, and that would be the gas pedal. Okay, so if you push on the gas pedal, it's going to cause your car to accelerate, and that makes sense. But what are the other ones? Well, your gas pedal is going to cause you to speed up. What's going to cause you to slow down? Because slowing down really is an acceleration, so we have to include that in the list. Well, your brake. Brake will cause you to slow down. And what's going to cause you to turn? Because turning is an acceleration, so we have to include that as well. Well, the steering wheel. And the steering wheel is also considered accelerator. So can you imagine driving down the road and your dad's riding shotgun? He says, "All right, maybe you're traveling down the interstate." And he says, "All right, I'd like you to accelerate." So you look over your dad, accelerate. Okay, I'll accelerate. And so you push push on the brake, and your dad looks over you and why'd you slow down? Well, you said accelerate. And you said, I know, accelerate, speed up. No, he said, Dad, acceleration isn't just speeding up. It would also include slowing down and turning. So acceleration, speeding up, slowing down. If someone says if someone says accelerate and they're not specific, you could take the steering wheel and turn the steering wheel, and that too would be accelerating. All right, moving on to the next page. Run through average acceleration, and then we'll stop at question number 8. So average accelerations. This is a change in velocity divided by the time it takes. And so acceleration with an arrow on there, you don't necessarily need the CC, that's probably bad on my part. It's basically a change in velocity divided by a change in time. And you got to have the change in there. So velocity is a change, acceleration is a change in velocity. Anytime you change your velocity, that's how we classify the equation for acceleration. Okay, the next thing we need to do is run through the units. I'm going to zoom in a little bit because this is one that you're going to need to be able to pick up on quite well. Let's see if I can focus it in a little bit. All right, we know that velocity is going to be meters per second, and then like east, and time is going to be seconds. All right, for now, I'm not too concerned about the east part. We'll include that here in just a bit, but I just want to look at the meters per second per second. This is actually a unit of acceleration. If I were to go to the equation sheet, you can grab the equation sheet if you like, and include acceleration on there. You could say meters per second per second. That would be acceleration. But most people don't use meters per second per second. They use another concept. And so those that are sharp with their algebra can realize that we can put the seconds over 1. So this is really then meters per second times 1 over seconds. Remember, you have to invert and multiply. So if I simplify this, that'll be meters per second squared. And most of the time, when we talk about acceleration, we're talking about meters per second squared, not meters per second. Although meters per second is correct, we want to just use primarily meters per second squared. So if I come back over here on my sheet, I'm going to go ahead and put meters per second squared. I could also say miles per hour squared. Basically any distance divided by any time squared. Now if you want to come back and put your direction on there, I would have not a problem with that. That would be perfectly fine. Alright, and that's the video.